Hi guys, it's Miss Andrews. I ended up having a meeting at the district office today that I hadn't planned on, so I wanted to make sure that we got through the rest of Chapter 17 with a decent amount of instruction. So what I'm going to have you guys do is, well, hopefully you already did the warm-up. If not, I'll have the sub paused. And then, so then we'll go over it. And, yeah, then you can't ask questions because I'm not there. But as we go through all this, with stops and starts here and there, make sure that you write down any questions, take note of them. And then the last half hour of class, wherever you are in this process, you guys will have the quiz, which I'm going to go ahead and make a group quiz. And then we'll go over that at the beginning of class on Thursday. There will also be a practice test for you to work on between now and Thursday. Try to do as much of that as you can so that you also come prepared with questions on that on Thursday. All right. So if we're looking at 8 frogs, sorry, just kidding. 1 out of every 8. So our probability of success, P is 1/8, and our Q, our probability of failure, that is not having the trait, is 7/8. So the probability that none of the 12 frogs would have it, so probability that X equals 0. So X, specifying that, is number of frogs out of 12 that have the trait. Okay, back to what we were doing. So none of the 12 frogs, so that's 7 out of 8 to the 12th. And that one is only going to happen one way, so it doesn't get too complicated. I, dang it, don't have a graphing calculator with me, so I can't do that. But I can tell you how to put it into the calculator, and I can tell you how to set it up. And then later on, I can get the numbers in there. The probability at least 2 of the frogs. So that's the probability that X is greater than or equal to 2. So that is, we need the 12 choose 2 times the probability of success to the, oh goodness gracious, second, 7 out of 8 to the 10th. And that needs to be added to, and this is where I totally run out of room, so that would be 12 choose 2, and then plus 12 choose 3, and 12 choose 4, and 12 choose 5, up to 12 choose 12. There we go. Sorry. And that would be to the 12th. And none to the 10th, so you don't really have to, or sorry, to the 0. So the probability that they wouldn't have it to the 0. The way that you're actually going to find that is by doing 1 or fewer. So 1 minus the probability of 1 or fewer. So to calculate that, you get the binomial CDF. N, so 12, P, 1/8, and at least 2, so that would be 1 or fewer. So there we go. And then 1 for your last term there. And of course, because I don't have my calculator, I don't know what that is. So my apologies. We can double check that when we come back. But hopefully you guys can put that into the calculator. It's in the second bars menu. And then double check all that so you guys can compare to each other. 3 or 4 frogs. So that would have to be probability that x equals 3 or 4. That's the little union sign. I'm not sure that's the correct notation. I'd have to double check on that. And I'm going to undo that, and then I'm going to move this up because we're going to seriously run out of room. Okay, so the probability that x would equal 3 or 4. So that's the probability that x would equal 3 plus the probability that x would equal 4. So that has to be 12 choose 3. So probability of success to the third times the probability of failure to the ninth. So 12 minus 3 would give us the 9. And then plus 4. So 12 choose 4. 1/8 to the 4th times 7/8 to the 8th. And the way you'd find that is binom PDF 12, 1/8, and 3 plus binom PDF 12, 1/8, and 4. You add those two together. I really do apologize for not having the calculator and being able to give you that actual answer. Then part D, probability that no more than 4 out of the 12 frogs, so that would mean 12, or sorry, not 12, 3 or fewer. So the probability that x would be less than or equal to 3 is a far more easy calculation, but the notation is obnoxious. So that is 12 choose 0, 12 choose 1, 12 choose 2, 12 choose 3. So we do that the same way with that ... that I did above. So 0 for the successes, 12 for the failures, plus ... up to 3. So 1/8 to the third, 7/8 to the ninth. And you find that with binom CDF, and that one automatically calculates the number or fewer. So you can just put in 12, 1/8, and 3. And that will calculate it for you. So this notation here, oh, I missed a plus. Right here, this is acceptable for indicating that we're looking at anywhere from 0 up till 3. Same thing here, anywhere from 2 up until 12, so that plus ... plus indicates that you're including everything in between there. Okay, so that was that one. Moving on. I sincerely apologize. And I will see you guys on Thursday, and I'll answer any questions you have at that point. Thanks a lot. I picked out some of the things from the Chapter 17 slides that we're not going to go over, the keynote slides, that I would suggest that you do. They're good problems. We simply weren't going to have enough time to get through them all. So, but they're good practice with everything from Chapter 14 up through Chapter 17. All right. So, An archer has an 80% chance, hits the bullseye 80% of the time. Oh, I would pause the video here and work on these, and then unpause, and I will go over them in a minute. All right, so hopefully you paused and came back. So that means our P is, once again, as it has been a couple of times now, 80%, and Q is 20%. That wasn't on purpose, that just keeps kind of happening. What's the probability that her first bullseye comes on the third arrow? So that's a geometric question because it's when the first one is happening. Oh, sorry. So that's the probability that X equals 3. X equaling first success on this particular one. That's going to change. So that is 2 failures. So 0.2 to the second times the success. And once again, no calculator, and I'm not going to mess with it on my phone, so I'll let you guys do those calculations. She misses the bullseye at least once out of 6 arrows, so that's the binomial. So at least once, remember, is the complement of none. So what I'm going to do is the probability. So now X equals, or X represents the successes out of 6. I should say bullseyes out of 6. So the probability that she misses at least once. Oh, maybe I want to change that. In this case, I'm going to make X non-bullseye out of 6. Wow, I can't manage to do anything right now. Okay, so the probability that X is at least once, so missing at least once, is 1 minus the probability that she misses none. So 1 minus, that would be 0.2 to the 6th. So she misses every single time, versus missing at least once. So 1 minus the probability that she, did I just screw that up? Okay, so I just changed the X equals to the number of misses out of 6, which is the same thing, but it was just not making very much sense to me. So then the number of misses would be at least 1. So 1 minus missing 0. So 1 minus probability of failure 0.2 to the 6th. So that's how that's calculated. My apologies for that little stumble. So the probability, the first bullseye comes on the 4th or the 5th arrow. That one is actually geometric, calculated similarly to part A. We just need to add 2 of them together. So X is, again, the first success. And that's really only important for the notation. The probability equals 4, X equals 4 or 5. So for the 4, that is 0.2 to the 3rd, and then times 0.8. So that's indicating 3 misses, and then bullseye. We're going to add that to 0.2 to the, why would it be, God, no. Sorry, if you were wondering why that was a 3, it was because it was not supposed to be a 3, because, yeah, it was, oh my goodness, I shouldn't, that's like 8 o'clock tonight, so I really shouldn't do these things, apparently, outside of the school day, but, so 3 misses, then hits on the 4th arrow. It was right the first time. And then 4 misses, and then hits on the 5th arrow. So we add together those 2 probabilities. Get whatever you get out of your calculator. Again, sorry. It must be very unsatisfying not to get the full answer there. So probability, she gets exactly 4 bullseyes. So this time X is the number of bullseyes out of 6. So the probability that X equals exactly 4 is 6 choose 4, 0.8 to the 4th times 0.2 to the 2nd. So that would be indicating 4 bullseyes, 2 not bullseyes, 2 misses. So that's the 6 choose 4. Gives you how many possible ways that can happen. You find that with binom PDF, NP X, so N would be 6, probability of success 0.8, and 4 would be your number of successes. At least 4 bullseyes would be, and so the X is going to equal the same for parts E and F. So the probability that X is greater than or equal to 4, you can do 4 plus 5 plus 6, that's acceptable, or you can do 1 minus the probability of, or probability that X is less than or equal to 3, so 3 or fewer. That makes it easier to calculate in the calculator. I am sorry, but I'm not going to write out the entire thing because I'm going to run out of room in terms of like the notation as this part. But that would be the probability 1 minus the probability of 3 ... probability of 0. So the way I'm going to put that in the calculator is 1 minus binom CDF. So that would be 6 for your N, 0.8 for your P, and 3 for your number correct. And the probability that she gets at most 4, so that's the probability that X is less than or equal to 4, and that is the binom CDF 6.8 and 4. I hope this is helping you guys because as I'm looking at it, it doesn't seem very helpful, but anyway. All right, moving on. So, if, and this may not be true for all calculators, but lots of calculators, when the number of trials gets too big, it can overload our calculator and the binomial setup, particularly if you do the n choose k, that number can get really, really large. So in those cases, we can use the normal model to approximate the situation if the success-failure condition is met. This is going to be something that you are going to use a lot over the next several chapters. The success-failure condition means that the sample size must be large enough to have at least 10 successes and at least 10 failures. And yes, you have to show the math on this. So you need to actually write out NP and actually put in the N and the probability of success, N being your number of trials. So your number of trials times your probability of success has to be greater than or equal to 10, and Q also has to be greater than or equal to 10. There are some conditions out there that say greater than or equal to 5. I don't know when is which. I will look into that because I just saw that on a scoring guideline last year and I forgot about it. So we'll get into that more in chapters 18 and 19 anyway. Okay, so consider the archer with the 80% bullseye rate. She'll be shooting 200 arrows in a large competition. So, pause, take a moment, and do these problems. Okay, I assume you unpaused or you never paused in the first place. So the mean is found by NP, and this is on your formula sheet. So 200 times your probability of success. So that's going to be 16. No, that can't be right. 160. Woo! 160 bullseyes. And the sigma, your standard deviation, is the square root of NPQ. So 200 times 0.8 times 0.2. I guess I don't need the 0. And I'm going to pause because I do need to actually calculate that. Okay, so what I got there was 5.6569. Done with my calculator on my phone, and I always screw up the numbers on those. So if that doesn't come out right, check with the people around you and make sure that that's correct. Otherwise, I'm going to be working off the wrong numbers. So, is the normal model appropriate here? So this is telling us to check the NP and NQ. So NP, we already know, equals 160, which is clearly greater than or equal to 10. NQ is going to equal 40, which is also clearly greater than or equal to 10. So yes, the sample size is large enough for 10 successes and 10 failures. Okay, so what's the probability that she would get at least 180 bullseyes? So now it's large enough to use a normal model. So what we're looking at here is our mean of 160, standard deviation of 5.6569. So we have totally lost my train of thought again. Sorry. We have a mean and a standard deviation, so we need to calculate a z-score. So z would be 180, our observed value, minus the mean of 160, divided by the standard deviation of 5.6569. Okay, so what we end up with is a z-score of 3.5355. So that is occurring way, way, way out in this teeny tiny little bit of the tail that is so minute that it's going to be very, very small, and we already know that for sure. Anything outside of 3 standard deviations is going to be very, very little. So to get the probability that z would be greater than 3.5355, or the probability that x would be at least 180, is going to be found by the normal CDF 3.5355, 99. And again, no calculator with those functions on it anyway. You should be getting something next to 0. Double check that you have, like if you get your answer and you get a decimal, make sure you look at the end of the line and make sure it doesn't say e to the something, e something. That would indicate scientific notation. It's going to be a very small number. Moving on. Okay, so the next part of this is some AP FRQ practice. I am going to just go over, so I'm going to pause it and do my thinking, and then I'll unpause it. You guys don't need to know that I could have just paused and unpaused it. You should pause it, sorry, and work on the AP FRQ practice. I'm hoping I'm keeping you guys entertained for today in my absence. So pause, I'll see you guys in like 15 minutes. All right, after doing some of this, I just realized that it's probably better if you just look at the guidelines and I talk about them when we look at the scoring guidelines. Okay, so the probability that Sam's first upgrade will occur after the third flight. This can be some tricky wording. So after the third flight means that it doesn't happen on the first flight or the second flight or the third flight. So it happens at the fourth or more. So what's the probability, pardon me, that Sam will be upgraded exactly 2 times in his next 20 flights? He'll take 104 flights next year. Would you be surprised if he received more than 20 upgrades to first class during the year? Looking back to see what the question was. Trying to make you guys dizzy and confused. So, take 104. Would you be surprised if he received more than 20 upgrades? So, we'll go to the part A. So, let Y denote the number of Sam's, I used X, how long it takes until he receives his first upgrade. Geometric distribution, 0.1, because it has to do with the first upgrade. So what they have here is 1 minus the probability that Y is less than or equal to 3. This felt a little binomial at first because of this process, but because we don't know what the sample size is, it has to be geometric, which means we're going to calculate the probability that it happens on the first flight, the probability that it happens on the second flight, and the probability that it happens on the third flight. And then we're going to add all those together. So 0.1 times 0.9 times 0.1, that's so first upgrade on the second flight, and then 0.9 to the second times 0.1, so that's 2 failures and then an upgrade. And then we do 1 minus that because this fourth or more to get the upgrade could go out to infinity. So what we end up with there is 0.729. So I'm going to blow up the how you score that. Essentially correct if the work includes a correct probability and shows supporting work. An alternative is the first upgrade after the third flight, no upgrade on flight 1 or 2 or 3 equals no upgrade on flight 1 and no upgrade on flight 2 and no upgrade on flight 3. So that's the other way to go about it. Seems easier now that I look at it. You do have to show your calculations though. So partially if you include a correct calculation of related probabilities such as y equals 3, 0.9 times 0.9 times 0.1, and you calculate that, or y equals 4, 0.9 times 0.9 times 0.9 times 0.1, with supporting work. The supporting work has to be there, or that the response includes a correct probability with insufficient supporting work. So you can have your correct probability, but if you don't have your work showing and what it is you're finding, then it doesn't work. So something that I want to note, if you have just the calculations, just that and nothing else with an answer, that should be scored no higher than a P. So I have not shown you the Geomet CDF because it seems ridiculous to try to remember, but that's also in the second VARS menu. Okay, so then there we go, unless the value of 1 is labeled as P somewhere in the response, which is the case. In that case, the score should be given an E. So that means you just have to make sure everything is there. Incorrect if the answer is provided with no supporting work, or an unreasonable probability greater than 1 or less than 0 is provided. All right, shrink that back down. Okay, next, that's a binomial. Finally, part C. Right. Where's my pointer? There we go. So 20 choose 2, 0.1 to the first for his 2 failures. Just kidding, for his 2 successes, so his 2 upgrades, and then 0.9 to the 18th for his 18 non-upgrades. Essentially correct if you include the correct probability and supporting work. Partially correct if the supporting work makes a calculation mistake that results in a reasonable incorrect probability. For example, 0.1 to the second times 0.9 to the 18th should be scored as partially correct, or if the response includes a probability with insufficient supporting work. Here again, the calculator command binomial PDF with no other justification is no more than partially correct, unless somewhere in the response the value 0.1 is labeled as P and the value of 20 is labeled as N. So if you put all this in, if this is what you show for your justification, you also have to say N equals 20, P equals 0.1, and I would also say for my scoring purposes that X equals 2. If the response in part A was downgraded to a partially for a failure to identify the geometric parameter, do not downgrade in part B for the same oversight. So there's that. So, okay, let's look at the scoring one more. A couple ways to go about this. The number of upgrades Sam will receive in 104 flights. The random probability follows the binomial distribution. So the calculation for that, being greater than 20, is probability to be less than 20. So there's one way to go about it. It's very unlikely you would receive more than 20 upgrades if the airline's claim is correct. You can also do that. No, I guess not. I guess it's not that. Okay, sorry. Just checking on something. NP and NQ would both be greater than 10, so you could use a normal model here to calculate the probability of that happening, or determine guidelines, but you can calculate it that way. But I would probably do that with the normal model, because you have an NP of 10.4 and an NQ of whatever 104 minus that is. So then you could use a normal model and calculate the z-score for 20 and then find the probability of being greater than that, which would also be very small. So there is that. I don't know if any of that helped you at all, because I feel like all the screw-ups that I usually make during class are going unexplained and unpointed out. But anyhow, next up, go ahead and work on the scoring guidelines, scoring overall. 3 parts partially correct. Sorry, all 3 parts essentially correct for a 4, so on and so forth. So that's your practice. Anyway, so you guys have the rest of the class period to finish or to do the group quiz. When you're finished with the group quiz, get the practice test from the sub. And that is that. So hopefully this helped. If it